Okay, in the previous video, we talked about evaluating limits, but we used some algebra techniques to evaluate them. So in this case, we're going to use what I call the nearsighted approach, because all you're doing is looking closely at the graph to figure out how to evaluate the limit. And we did a little bit of that in class today. Notice also we're going to talk about approaching a limit just from one side, and that's this notation here. If we zoom in real close, this means what's the limit of f of x as x approaches 2 from the negative side or from the left side. And this is what's the limit of f of x as x approaches 2 from the positive side. So that's just some notation that I want to make sure you're familiar with. So in this case, number one, it says refer to the graph to find each limit if it exists. If it doesn't exist, we put does not exist. Okay, so part A is what's the limit of f of x as x approaches 2 from the left. So we're talking about this thing right here is my f of x. And as we approach from the left, let me get a highlighter. As we approach from the left, we're coming along this guy. I said highlighter. Why are we not highlighting? Sorry. Huh. Oh, let me go to draw. I know how to do this. There we go. Okay. So as we're coming along from the left, we're coming along this thing, and we're asking ourselves, what is it getting close to? And the function is getting closer and closer to 3, because you can see it right there. So part A would be 3. When we go to part B, it's saying we're approaching f of x from, or we're approaching 2 from the positive side. So as we get in closer to 2, we're coming along this guy, and we come in right like that. And it looks like we're getting closer and closer to -1. And then if you look at C, C is asking what happens if I approach 2 from both sides at the same time, because you can see there's no little number there, right? Or no little sign there. So now when I'm approaching 2 from both sides, or from the same side, or when I'm approaching 2 from both sides at the same time, okay, so if we're approaching from both sides at the same time, then, well, they don't agree, because as I come in from the left side, it's saying that I'm getting close to 3. As I come in from the right side, it says I'm getting close to -1, which means the answer for C would be does not exist. Wait, what are you doing there, buddy? Well, that's funny that it's not. So sorry, there's a little glitch in the system. I'm not sure what happened. So anyway, we already found that A is 3, and part B is x approaches 2 from the positive side. That's -1. Then we're on C. As x approaches 2 from both sides at the same time, we find out that these don't agree. So that would be does not exist, because it's not approaching one thing. So then if we do part D, we're approaching 0. X is approaching 0, so here's 0 right here. So as x approaches 0, it looks like, from the left side, it looks like we're approaching 2. On the right side, it looks like we're approaching 2 again. And so when we say, let's let approach 0 from both sides at the same time, then, well, the right side and the left side agree, so that means that we would say it's approaching 2. Okay, let's look at well, I guess this is the second part of number 1. So part A, we're approaching 2 from the left side. So here's 2 right here. So as we approach 2 from the left side, it looks like it's headed towards 1, 2, 3, 4. As we approach 2 from the right side, it's sitting on 4. So we would say 4. And once again, they agree. So that means the answer would be 4 if we approach 0 from both sides at the same time. Now notice that if we were to ask the question, what is f of 0? The answer would not be 4, is it? The answer would be 1. So that's, of course, that's a different question than what we're asking. Okay, so then we go to the limit as f of x as x approaches 0 from the left side. That would be we're cruising down here, and it looks like it's approaching 1. If we come in from the right side, it's also approaching 1. So since they're approaching the same thing as we approach from both sides, then the answer would be 1. Okay. So if we continue with this, this says what's the limit of f(x) as x approaches 2 from both sides at the same time? Well, as we come in from this side, it looks like it's approaching 0. Come in from that side, it's approaching 0. Answer is 0. This says what's the limit of f(x) as x approaches 0? That looks like it's right about there. It looks like about negative 1.9-ish. Sorry. And now this is a completely different question. This is saying, what is f of 2? Well, f of 2 is actually negative 2, because that's where that little dot is, right? You see that dot? So you can see that these are clearly asking two different questions, and in this case, they get two different answers. Okay? Moving on to this next one. The limit of f of x as x approaches 1. So that would be coming in from both sides at the same time. It looks like it's headed towards 1. And this asks what's the limit of f of x as x approaches 0. That would be 2. And this, I don't know what I was thinking there. I asked the same question twice. Of course, that would still be 1. Sorry about that. Now, when we get over here, it says what's the limit of f of x as x approaches 1. See that little negative there? From the negative side. So that means we'll be coming down here, and it looks like it's headed towards 2. Then we say, how about if I approach from the right side? Approach 1 from the right side, that'd be coming in here, so that's at 1. And finally, the question was, what is f of 1? Well, f of 1 is 0, isn't it? So the limit as we approach 1 from the left side is 2. The limit as we approach 1 from the right side is 1. And the value of the function at 1 is 0. And if we could ask one more question, the limit of f of x as x approaches 1 from both sides at the same time, the answer would be does not exist, because they don't agree. All right, so that's a picture of trying to just evaluate limit when we're looking at the drawing. When we're looking at the graph, you're basically just, I call it the near side, because you're just getting real close to the graph and look at what's happening as x approaches whatever number it is that it's supposed to be approaching. All right, and that's a nice short, sweet video.